Hey, thank you for joining us here today. This is our Auburn University Electrical and Computer Engineering Senior Design Team's project and presentation. I'm Mac Butler.
I'm Trevor Petski.
I'm Stephen Auburn.
I'm Kevin Namey.
And our project is an animal intrusion detection and deterrent system for Florida Power and Light substations. Florida Power and Light has an animal intrusion problem in their substation that frequently causes power outages and has contacted Auburn University for a solution. Last semester, another team began to work on the project with an inexpensive camera and their own built-in analytics. Unfortunately, they ran into problems because the quality of the camera was too low. When we picked up the project, our main goal was to find the new camera and build the system that was able to perform at a higher level.
Given their reputation for being the best on the market, we began the search for our camera by looking at FLIR's FC series cameras. We came across the FC series ID, or intrusion detection camera, with built-in analytics to detect humans, vehicles, and other objects of interest coming in and out of the picture. We contacted Steve Mann, a FLIR representative, in order to test this model out and met with him in person at Auburn to learn more about the capabilities of the camera. We decided that this camera fit our needs for the project, so we had Steve loan us a demo camera for the rest of the semester.
In order to use the camera properly, we had to get a mount for the camera and successfully connect it to the router. Shortly after receiving the camera, we began to test its capabilities. First, in order to get a feel for how the camera works, we would set it up in my house for the weekend and directed it in an area with high volumes of small animal traffic. The camera allows for us to set a tripwire around the area of interest, which then takes a screenshot of the area when something comes into the picture. This test proved the camera to be very capable of taking high-quality thermal images upon intrusion into the area of interest. We then had a conference call with Bud and Joe from Florida Power and Light and told them of our findings. They then expressed concern about the camera's ability to detect small animals of interest in the presence of hot transformers in their substations. In order to test how the camera handled other hot objects in the background, we set up the camera outside of Brown Hall facing a street with high volumes of pedestrian and vehicle traffic. We found that the camera is capable of distinguishing between vehicles and people, and also that the camera did not have trouble capturing pedestrians in the presence of reflective heat.
We then reconvened with Bud and Joe with our results from this test. We then all came to the conclusion that the camera is up to FPNL's standards. After coming to this conclusion, Bud and Joe expressed a need for a form of notification upon intrusion and a potential for more flexible analytics. We then began to brainstorm possible solutions to this. We decided that using a Raspberry Pi to handle the output of the camera would be a simple and cost-effective platform to build a notification and analysis system. The Raspbian operating system has a built-in Python development environment. We wrote a basic script to send an email when receiving an input from the camera. We can use the Pi to further develop ways to track date, time, and frequency of intrusions to review patterns of any intruders. Unfortunately, we weren't able to configure the camera's output, the built-in GPIO pins, which held us back from successfully sending the email notification. Luckily, we found that the camera has a built-in capability to send an email notification upon intrusion. In order to test this capability, we set up a controlled experiment in which we had a dog walk through the picture and watched for an email notification. We were able to receive an email with the screenshot every time that the dog walked through the picture. Though our intention of developing our own email notification system has many parallels with FLIR's built-in capability, our own system would allow us to configure the camera's output and run our own analytics on it.
Coming into the project, we had the goal of finding out if the camera suffices FPL's needs that comes successfully detecting animal and upon interest in when it happens. Through multiple conference calls with FPL, we were able to tailor our tests to the input that Bud and Joe gave us based on their problems and where they want to go with the project.
After extensive testing, we found that our camera does meet FPNL's needs for an intrusion detection system. Also, our Raspberry Pi system has the potential to allow FPNL as well as the next team to inherit our project to run their own analytics on the camera's output.
Thank you.